Step into the world of aircraft mechanics, the unsung heroes who keep our skies safe. Their daily routines blend technical expertise with meticulous attention to detail. Join us as we explore the challenges, responsibilities, and rewards of this vital profession. 135000 plus active mechanics. The U.S. aviation industry relies on over 135,000 certified aircraft mechanics according to 2024 BLS data. Safety guardians. These professionals ensure every aircraft meets stringent safety standards before each flight. Reliability experts. Their work maintains optimal aircraft performance and prevents costly flight delays. FAA certification. Earn airframe and powerplant (A&P) licenses after completing 1,900 hours of training. Entry-level positions. Begin career at regional airlines or smaller maintenance, repair and overhaul facilities, MROs. Career advancement. Progress to major airlines, specialized roles, or leadership positions with experience. Senior positions. Become a lead mechanic, inspector, or maintenance director after 10 to 15 years. Regular inspections. Daily pre-flight checks. Routine maintenance inspections. Non-destructive testing. Repair procedures. Component replacement. Structural repairs. Troubleshooting systems. Documentation. Maintenance logbooks. Regulatory compliance records. Service bulletin implementation. Quality assurance. Final inspections. Operational tests. Return to service certification. Commercial jets. Boeing 737 and Airbus A320 families make up 80% of commercial narrow-body fleets globally. Business aviation. Corporate jets like Gulfstream, Bombardier, and Cessna require specialized maintenance protocols. Regional aircraft. Turboprops and regional jets connect smaller markets with distinct maintenance challenges. Hangar facilities. Large enclosed spaces for major maintenance checks and overhauls. Temperature controlled with specialized equipment docks. Line maintenance. Outdoor work on airport tarmacs in all weather conditions. High-pressure environment with tight turnaround times. Component shops. Specialized workshops for avionics, hydraulics, and engine repairs. Clean room environments for sensitive components. 5:30 a.m. Arrive at facility, change into uniform with safety equipment. 6 a.m. Team briefing covers overnight issues and day's maintenance priorities. 6:15 a.m. Supervisors assign specific aircraft and tasks to mechanics. 6:30 a.m. Gather necessary tools and equipment for assigned maintenance tasks. Before touching an aircraft, mechanics must thoroughly review maintenance history. They check logbooks for deferred items and recurring issues. Each discrepancy must be documented according to strict FAA regulations. Electronic systems now complement traditional paper records. Exterior surface check. Carefully inspect fuselage, wings, and tail for dents, cracks, or missing fasteners. Look for signs of fluid leaks or damage. Landing gear inspection. Examine tires for wear, proper inflation, and brake condition. Check struts for proper extension and hydraulic leaks. Engine assessment. Inspect engine nacelles for damage, fluid leaks, and loose components. Check fan blades visually for foreign object damage. Control surfaces verification. Confirm proper movement and condition of ailerons, rudder, elevators, and flaps. Look for binding or unusual resistance. Systems pressurization. Verify hydraulic, pneumatic, and fuel systems maintain proper operating pressures under load. Control actuation tests. Operate flight controls through full range of motion. Check for proper response and feedback. Avionics verification. Power up navigation, communication, and monitoring systems. Confirm accurate readings and proper function. Final documentation. Record all tests performed according to FAR 121.369 requirements. Sign off on airworthiness documents. Identify problem. Review pilot reports and fault codes from onboard diagnostic systems. Consult documentation. Reference manufacturer maintenance manuals and troubleshooting guides. Perform diagnostics. Use specialized tools to test systems and isolate the fault. Implement solution. Repair or replace components following manufacturer procedures. Verify repair. Test the system to confirm the issue is resolved before return to service. Daily interactions. Typical communications between mechanics and other departments per shift. Time savings. Effective communication reduces troubleshooting time on complex issues. MEL items. Average number of minimum equipment list items tracked per aircraft. Effective coordination between maintenance crews and flight operations is essential. Clear communication about aircraft status prevents delays and ensures safety. Oil change. Average time, 4 hours. Complete drain and replacement of engine lubricants according to manufacturer specifications. Brake replacement. Average time, 3 hours. Removal and installation of brake assemblies with precise torque specifications. Tire change. Average time, 1.5 hours. Removal of worn tires and mounting of new aircraft-grade tires with proper inflation. Filter replacement. Average time, 1 hour. Inspection and replacement of fuel, oil, and air filtration systems. Lubrication service. Average time, 2.5 hours. Application of specialized lubricants to moving parts including control surfaces and mechanisms. Routine maintenance follows strict schedules based on flight hours and cycles. Each task must be performed according to manufacturer specifications with approved parts and materials. Parts identification. Locate exact components using part numbers and aircraft specifications. Inventory management. Track components using Ramco or quantum control software systems. Documentation verification. Confirm authenticity with FAA 8130-3 or EASA Form 1 certificates. Supply chain coordination. Source OEM parts through approved vendors and distribution channels. A-check, 6 to 10 hours. Basic inspection performed every 400 to 600 flight hours. C-check, 1 to 2 weeks. Intermediate maintenance every 4,000 to 6,000 flight hours. D-check, 30 to 45 days. Complete aircraft overhaul every 6 to 10 years. Airline profitability depends on minimizing aircraft downtime. Delays can cost up to $8,500 per hour in lost revenue and compensation. Shift type. Break schedule. Rest requirements. Day shift, 8 hours. 30-minute lunch, 2 15-minute breaks. 10-hour minimum between shifts. Night shift, 10 hours. 45-minute meal, 2 20-minute breaks. 12-hour minimum between shifts. Heavy check, eat 12 hours. 60-minute meal, 3 15-minute breaks. 16-hour minimum between shifts. OSHA and company policies mandate adequate rest periods. Fatigue management is critical for maintenance quality and safety standards. Some facilities provide dedicated rest areas with facilities for hot meals and quiet relaxation. Problem diagnosis. Mechanics use advanced diagnostic tools to pinpoint the cause of reported issues. Component removal. Faulty parts are carefully removed following detailed manufacturer procedures. Replacement installation. Team-based approach ensures proper installation and connection of all systems. AOG notification. Aircraft on ground status triggers emergency response protocols. Affects 40,000 plus flights annually worldwide. Response coordination. Dedicated AOG desk mobilizes appropriate maintenance teams and resources. Parts logistics. Expedited shipping and customs clearance for critical components. Rapid repair. Specialized teams perform repairs with heightened urgency and oversight. System testing. Operational checks confirm all maintained systems function properly. Area inspection. Visual verification ensures all components are properly secured and panels closed. Tool accountability. Each mechanic accounts for all tools to prevent foreign object damage. Logbook sign-off. Certified mechanics approve aircraft for return to service with signature and license number. Aircraft maintenance requires strict adherence to multiple regulatory frameworks and comprehensive documentation practices. FAA requirements. 14 CFR Part 43, Maintenance Standards. Part 65, Certification Requirements. Part 121 to 135, Operator Requirements. U.S. mechanics must document all work according to strict federal regulations. Record keeping. Detailed maintenance logs. Component tracking by serial number. Digital and physical archives. Records must be maintained for the life of the aircraft and be readily accessible. International standards. EASA, European requirements. ICAO, global standards. IATA, industry best practices. Global operations require compliance with multiple regulatory frameworks. Modern aircraft maintenance relies on precision tools and advanced technology. Specialized equipment must be calibrated regularly to maintain accuracy. Augmented reality systems now assist mechanics with complex maintenance procedures on newer aircraft models. Personal protective equipment. Safety glasses, hearing protection, and specialized gear protect mechanics from workplace hazards. Lockout to tag-out procedures. Critical systems are locked out during maintenance to prevent accidental activation. Hazmat controls. Strict protocols for handling hydraulic fluid, fuel, and chemicals reduce exposure risks. Emergency response. All mechanics receive training for fire, chemical spills, and first aid situations. Time constraints. Mechanics often face tight windows to complete repairs before scheduled departures. Each minute counts toward on-time performance metrics. Safety responsibility. Every decision directly impacts passenger safety. Mechanics must balance thoroughness with efficiency without compromising either. Complex troubleshooting. Intermittent issues can be difficult to diagnose. Mechanics must apply systematic thinking while under operational pressure. Real-life example. A mechanic once improvised an emergency patch on a hydraulic leak minutes before departure, preventing a costly delay while maintaining safety. Extreme temperatures. Working in 120 degrees Fahrenheit ramp heat or minus 30 degrees Fahrenheit winter conditions requires specialized gear and modified procedures to maintain precision work. Lightning restrictions. Safety protocols halt outdoor maintenance during thunderstorms, creating scheduling challenges for time-sensitive repairs. High winds and precipitation. Challenging conditions for precision work and component handling require additional precautions to prevent FOD, foreign object damage. Mechanics must adapt to environmental challenges while maintaining work quality. Specialized gear and equipment modifications help overcome extreme conditions. Cross-functional teams. Airframe, avionics, and power plant specialists work together on complex issues. Shift handovers. Detailed communication ensures continuity between departing and arriving crews. Operations coordination. Regular interaction with dispatch, flight crews, and ground operations. Collaborative problem solving. Complex issues often require multiple specialists to diagnose and resolve. Initial certification. 1,900 hours of FAA-approved training plus written, oral, and practical exams. Aircraft type ratings. Specialized training for specific aircraft models like Boeing 737 or Airbus A320. Recurrent training. Annual refresher courses on regulations, safety, and new technologies. New technologies. Ongoing education on composite materials, electric propulsion, and avionics. Labor shortages. The industry faces a critical shortage with over 10,000 unfilled positions in the US alone as of 2023. Aging workforce retiring. Fewer new entrants. Competition from other industries. Addressing shortages. Industry initiatives to fill the pipeline with qualified mechanics. Scholarship programs. Military transition pathways. Improved compensation packages. Physical demands. The work requires strength, dexterity, and stamina in challenging positions and environments. Awkward working positions. Heavy component lifting. Repetitive motion injuries. Ergonomic solutions. Innovations to reduce physical strain and extend careers. Ergonomic tools. Mechanical assist devices. Job rotation strategies. Safety record. Commercial aviation safety rate achieved through meticulous maintenance. Average career length. Years many mechanics stay in the profession, indicating high satisfaction. Job fulfillment. Mechanics reporting high personal satisfaction in industry surveys. Mechanics find deep meaning in their role as guardians of air safety. Many have been cited by name in preventing potential incidents through their attention to detail. Automated inspections. Drones and robots now perform visual inspections, accessing difficult areas while collecting more consistent data. Predictive analytics. AI systems analyze sensor data to predict failures before they occur, revolutionizing maintenance scheduling. Electric propulsion. Mechanics are developing new skills for maintaining electric and hybrid aircraft with different maintenance requirements. Safety guardians. Mechanics are the final line of defense in aviation safety, meticulously inspecting every component to prevent potential issues. Operational reliability. Their work ensures on-time performance and minimizes disruptions, keeping the complex global air transportation system functioning smoothly. Critical workforce. Their specialized skills cannot be outsourced or fully automated, representing an irreplaceable human element in aviation safety. Aircraft mechanics represent the perfect blend of technical expertise and personal responsibility. Their commitment to precision makes modern air travel possible. Consider supporting this vital profession through advocacy, education initiatives, or even pursuing it as a rewarding career path.